Hello again. We continue chapter 11 with 11.8 power series. So what is a power series? The general form looks like the series from n equals 0 to infinity from a constant, depending on n, obviously, c0, c1, c, and so on and so forth, and x minus a to the nth power. Again, how does this look like? So it looks like when n is 0, then we have c0 plus x minus a to the first power, of course, c1, plus c2, x minus a to the second power, plus dot, 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 3 dots, plus, of course, cn, x minus a to the nth power, and it continues. So this is a power series in x minus a, also called centered at a, and also about a. So you can say power series in x minus a, or you can say centered at a, or you can say about a. Specific case when a is 0, we have a power series that looks like this. And of course, these power series converge for particular values of x and diverge for other values of x. There is one in which all cn's are 1 that we already know about, and it's this. N equals 0 to infinity is the geometric series, right? So when x is 0, we have 1 and plus x squared plus dot, 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 plus x to the nth, and continues. And we already know the sum. We calculated it with different coefficients, but the coefficients now are 1. All of them are 1. So we know the answer is 1 over 1 minus x. We know that this power series, we calculated this a long time ago, is convergent only, so convergent only for the common ratio being in absolute value less than 1, which means between -1 and 1. So it will be convergent. So the other thing that I was going to mention here is that, as you notice, a power series is a function, and of course the domain of this function, so let's call it f of x, domain of f of x is all x values for which this power series is convergent, for which Cn x minus a to n is convergent. Okay, one more thing we need to talk about before we look at examples. And this is my page 2. Something called radius of convergence and interval of convergence. So interval, the interval for which the domain, if you want, of this function, interval of convergence, and also radius of convergence. Okay, so back to the general form, Cn x minus a to the nth from n equals 0 to infinity. So for such a powered series, there are 3 possibilities. Possibility 1 is that the series converges only when x equals a. The second possibility is series converges for negative infinity to infinity, all x values. And the third possibility, the series converges for a particular R radius of convergence and interval. How does the interval of convergence, let me remove this. How does the interval of convergence look like? 4 different possibilities. And they are between a minus r to a plus r, open, a minus r, a plus r, both closed, a minus r, open on the left and closed on the right, and finally, a minus r, closed on the left and open on the right. So we have all the necessary information to start working on examples and see and find the interval of convergence and the radius of convergence for different series. Okay, so let's start with 13 on page 786. Okay, so in 13 we have this infinite series, x to the nth over n factorial, and from n equals 0 to infinity. Find the radius of convergence and interval of convergence of the power series. In general, we will be looking at the ratio test, root test, and also please remember, check endpoints. So these are things to remember. We are employing here the ratio and the root test, one or the other, and always check the endpoints of the interval of convergence that we find. So let's see how we address this. So I'm on page 3. Okay. So directly with the limit for the ratio test, as n approaches infinity, from x to n plus 1 over n plus first factorial, n factorial over n, x to the n factorial, x to the n. So when we simplify this, there is an x. Here, however, take it easy, factor, or basically expand a little bit, just a little bit. This is n plus 1 and n factorial. Now see what happens when n approaches infinity. This is 0. Remember the ratio test, the answer, the limit has to be less than 1. So it is less than 1, and we didn't determine any x. So the radius of convergence is infinity, and the interval of convergence is all real numbers, all x values. Any x will make this series convergent. So if this is a function, its domain will be all real numbers. Okay, moving on. Let's continue with number 15. And 15 has, and I didn't mention, did I mention 7? Yes, 786, of course. Page 786. Okay, so in 15 we have x to the nth divided by n to the 4th times 4 to the nth power from n equals 1 through infinity. Okay, so again, we are going to use the ratio test. And always remember to check the endpoints. So limit as n approaches infinity, x to n plus first, n plus 1 to the 4th power, 4 to n plus first power, and then flip n to the 4th, 4 to the nth, x to the nth power. Okay, so let's see what we get here. I'll simplify and get a 4 here. I'll simplify and get an x at the top. And this limit, when n approaches infinity, n to the 4th and n to the 4th, this limit will be 1. So then the answer is the absolute value of x over 4, which must be less than 1 for convergence, based on the ratio test. So then x over 4 less than 1, translates, as you know, from algebra to -1 less than x over 4 less than 1. Multiply all three sides by 4, -4 less than x less than 4. So for now we know that the radius of convergence is 4. And what we need to determine is continue finding the endpoints and analyzing the endpoints. So x equals -4 and x equals 4. Since I don't have enough room here, I'm going to move on to the next page. So for x equals -4 and later on for x equals 4. Now remember the series, so I'm going to copy it here just to have it handy. X to the nth power, n to the 4th, and 4 to the nth. Okay, so when we replace x by -4, we get -1 to the nth power and also 4 to the nth power. I split x into -1 and 4. So -1 to the nth, 4 to the nth, over n to the 4th, 4 to the nth. These two go away. This is an alternating series. We've seen this before. So we know that bn plus 1 is definitely less than bn, the first condition. And the second condition, the limit that bn as n approaches infinity is 0. Both conditions are fulfilled. Therefore, this series is convergent by the alternating series test. So then I will go back and include -4. Now let's see if we include x equals 4. N equals 1 to infinity. 4 to the n over 4 to the n. This will be 1 over n to the 4th, which we know is a p-series. Convergent, because p is greater than 1. P is 4 here. So then I'll go back and confidently include the other endpoint of the interval. So therefore, the radius of convergence is 4, and the interval of convergence is -4 to 4. Okay, moving on. Let's move on to 17. On the same page, 786. In 17, we have the series from 1 to infinity, -1 to the nth power, again 4 to the nth, x to the nth over the square root of n. Okay, so let's see what we get on this one. Again, the limit as n approaches infinity. I will use the ratio test. -1 to n plus 1, 4 to n plus 1, x to n plus first, all of them, square root of n plus 1, and I flip the square root of n over -1 to the nth, 4 to the nth, x to the nth. Okay, so after simplifications, let's see what we get. A 4 is left up here, an x is left up here. This limit will be 1, no problem there. So -1 to n plus 1 minus n will be -1 to the first power, which is negative. So this will be -4x in absolute value, which has to be less than 1. But -4x in absolute value is the same with 4x in absolute value. So I have -1 less than 4x less than 1. I divide both sides by 4, and we get, let me write it on the next page. Okay. -1/4 less than x less than 1/4. The radius of convergence is 1/4. But now the question is, what happens at the endpoints? So we're going to analyze x equals -1/4, and we're going to analyze x equals 1/4. Okay, so n equals 1 to infinity, -1 to the nth power, 4 to the nth. But now -1/4 to the nth will be -1 to the nth times 1/4 to the nth, and everything divided by the square root of n. So of course, these two go away because -1 raised to power 2n is going to be positive 1. These will go away. So the simplified form will be n equals 1 to 1 over the square root of n. We discussed this series before, and here, p here is 1/2. So the series diverges as a p series. Okay, so in this situation, we cannot include -1/4. So we have to analyze now 1/4. So let's see what happens with 1/4. -1 to the nth. Again, we had 4 to the nth power times 1/4 to the nth power. So they go away. But this is an alternating series. And the two conditions are that the limit of Bn is 0, and it is. And the other one that is decreasing, and it is. 1 over the square root of n plus 1 is definitely smaller than 1 over the square root of n. So this series is convergent by the alternating series test. So then I have to go back and include 1/4. So then, again, the interval of convergence will be -1/4, comma 1/4 closed, with a radius of convergence 1/4. Okay, let's look at two more. Uh, 21, same page, and we have a series from 0 to infinity, x minus 2 to the nth power divided by n squared plus 1. Okay, how are we on time? Almost close. So then limit n approaches infinity, x minus 2 to the n plus first, n plus 1 squared plus 1 times n squared plus 1 over x minus 2 to the nth power. So when we simplify, there is an x minus 2 left, and this n squared with n squared, the limit will be 1. So this answer is the absolute value of x minus 2, which has to be less than 1. So -1 less than x minus 2 less than 1. So the radius of convergence is 1, and we add 2 to both sides, and we get 3. 1, 3. So the interval so far is 1, 3. However, we have not discussed x equals 1, and we have not discussed x equals 3. So let's see what happens in this case. So for x equals 1, we have the series -1 to the nth power over n squared plus 1. And for n equals 3, we have 1 to the nth power, which is 1, 1 over n squared plus 1. This is an alternating series. It's decreasing, so Bn plus first less than Bn, and the limit of Bn is 0. Both conditions are fulfilled, so this is convergent by the alternating series test. I go immediately and include 1. This 1 over n squared plus 1 we know is less than 1 over n squared, which is a p series, which is convergent because p equals 2. So this series converges by the direct comparison test. Therefore, I go back, include both ends, and I will say no, the actual interval of convergence is 1, 3 closed. Okay, so let's also take a look at one more here. So page 7 for me here. Okay, 25. Same page, 786. And we have the series from n equals 1 to infinity. X minus 2 to the nth power over n to the nth. Obviously, this is typical for the root test. So the nth root of the absolute value of x minus 2 over n everything to the nth power, which turns out to be limit as n approaches infinity from x minus 2 over n, which when n approaches infinity, this is 0, which is always less than 1. So conclusion is the radius is infinity. And again, the interval of convergence is all real numbers. Thank you.